Hello and welcome to a video about controlling the heart. In this video, what we're going to talk about is how does the heart control the different sections of the cardiac cycle. So as we discussed in my cardiac cycle video about the fact that you've got different processes such as aortic systole and diastole and ventricular systole and diastole. The atrium and ventricles on both sides, on the left and right hand side of the heart, both beat simultaneously. It doesn't happen where the left side will happen first and the right side will go. So the question we've got is how does the heart actually control this? How does it make sure that the cycle happens in the correct order and where it needs to? Cardiac tissue is myogenic. That basically means that it will beat outside of the body. It will control its own beat. So we're going to look to see in this video about how the heart actually does that. Heartbeat initiation is basically centered around two nodes, the sinoatrial node and the atrioventricular node. Your sinoatrial node is known as your pacemaker's region. And what it does is it will start the signal. It's where the electric signal starts to initiate the heartbeat, and it will pass the message through the cardiac tissue through to the atrioventricular node. So your sinoatrial node is where the electrical signal starts, and it will send out at regular intervals to ensure the heartbeat is regular. And it will then pass from the sinoatrial node to the atrioventricular node. Once it reaches the atrioventricular node, it goes down the bundles of His. And the bundles of His are really insulated fibers. This is to ensure that our electrical signal only stays in the bundles of His and doesn't escape. And from there, the bundle of His then splits into the left side and the right side, and it's made up of something called Purkinje fibers. Now, your Purkinje fibers are uninsulated, and this spreads the signal across the walls, around the walls of the ventricles, to ensure that a contraction happens from the bottom of the heart up. So it empties the ventricle as a whole as that contraction happens. Okay, so bundles of His are insulated fibers around the outside walls of the heart, across the septum, and your Purkinje fibers run along the walls of the ventricles and are uninsulated fibers, and their job is to pass that electrical signal on. So, as the signal originates from the sinoatrial node, it passes across the atrium, allowing the atria to contract. It then reaches the atrioventricular node and is held there for a little bit before it passes down your bundle of His and Purkinje fibers. That holding is really important because what that means is that the ventricular diastole stays for a bit longer, allowing the atria to fully empty before the ventricle beats. If that wasn't the case, then the ventricle would beat and contract when it was half full or to three-quarters full, and the atria wouldn't fully empty, so it'd be an inefficient system. So this ensures that the atria empty and the ventricle are full before it beats, and the pressure in the ventricle then is big enough to pass through the aorta, the pulmonary artery, depending on where that blood is going. Now, when you hear about pacemaker operations, you hear about people's pacemakers being fitted, artificial pacemakers. It's really sinoatrial node cells have started to, something's gone wrong with them. So you can fit an artificial pacemaker there, which will help to maintain the pace of this beat. We can use this electrical impulse of the heart from the sinoatrial node to the atrioventricular node around the bundles of His and the Purkinje fibers to actually decide if the heart's working correctly or not. And that's where ECGs come in. So an ECG is just an electrocardiogram, and it monitors this electrical impulse, and it shows us with this familiar looking pattern, which can tell us whether the heart is working correctly or not. It's the PQRS complex. So in your ECG, in your PQRST complex, your P is a start of depolarization and a start of atrial systole. And then your QRS is your ventricular systole. And atrial systole ends at the end of this complex as well. And then T is your further depolarization and your start of your ventricular diastole. So we have depolarization and atrial systole. We have QRS, which is your ventricular systole. And then we have your T, which is now further depolarization. And your ventricular diastole. So this basically shows that the heart is beating normally if you have this kind of shape. Now, what you need to try to recognize is when it's not beating properly. So if we compare some ECGs, A is a normal patient, heart's absolutely fine, working perfectly. You can see the PQRST complex is looking healthy. Myocardial infarction is patient B, so patient who is suffering a heart attack. As you can see, it's slightly lower and it's completely out of sync. So while it may look regular, if you compare it to an initial ECG, it doesn't look the same. And your fibrillation is basically where it's completely beating out of rhythm. So there is no blood, there's going to be very little blood pushing around the body, and this would be likely to be caused either by a blockage or post myocardial or an actual myocardial infarction, a heart attack. And so you can see quite clearly there is no defined QRS complex there whatsoever. I hope this video has helped a little bit explaining how the heart initiates and is coordinated using electrical impulses and how we can use electrical impulses to tell if something's wrong with a patient. If you have any questions, please let me know, and comments below are welcome. Thank you.